Okay, so we're going to talk about what's going on with some cumulative frequency plot, also called Ogives. Okay, so that's kind of fun. We got our Ogives going on. So first thing I wanted to do is kind of show you how these Ogives are made. But you will not have to make these. I'm just showing you where they come from so you understand how they were developed. So the first thing that I want to do is we're going to talk about some data, as if I had given all of you a cup of M&Ms. You know, we've done that before where I scooped out a little cup of M&Ms, and then each student gave me the number of M&Ms that they have in their cup. Okay, so that's our situation to think about. So over here, here's what our little chart looks like. So we had, I guess, maybe, these are percentages, but however many people, this is however many people had between 30 and 40 M&Ms in theirs. And then what is this? What's going on here? This is a cumulative frequency histogram. It's actually a relative cumulative frequency. So is this the new people? All of that the new people? That is not all new people. What is it? Tell me, explain. See this little section of it? That's who was already in there. And then we added this section. So this is the additional percent of people who had between 40 and 50 in their cup. And so on and so forth. So, you know, what happens, so those people are counted in all of those. Here's the ones that are counted in all of these. So you can see kind of what gets added. So this group here is the section of people that had between 50 and 60, and so on. So what I want to do before we get started is, because I saw some people getting confused on this earlier in the day. Some people would look at this and they would tell me the shape of this distribution is skewed left. And I see that. I see that you see a histogram that is skewed left. But you have to keep in mind that this is an accumulation of data. So if I was to actually look at the shape of this histogram in its original form, let me do that. The original, so if this is 30 to 40, the original height of that bar is this. The original height of the bar that goes from 40 to 50 is just, this height right here. And so remember, that was that part that I added. And then this one, third, the amount of people that I added between 50 and 60 is probably about the same, maybe a little more. Okay? So do you see the original histogram that this came from? So this is the additional. So I'm going to put that size about right here. And then here's another one. See, this is all I'm adding right here. So that's another one that's about that tall. Let me see what I add here. I just add this much. So that's what the original size of the bar was, probably about just that much again. And then this one was a little taller. So the original histogram, what I'm getting at is the original histogram was not skewed left. Do you see that? I just wanted to clarify this shape because some people got confused earlier today. The original histogram is this shape, whatever we would call that. Okay, and that's not really the point today. So I just wanted to make sure you understood where these things come from. So here is then continuation. So after we make a cumulative frequency histogram, we put a dot at the maximum value. So that's what's happening right here. And then on your notes it says, then finally erase the histogram bars and connect each point. So this is how you make what's called a cumulative frequency plot, otherwise known as an ogive, a cumulative frequency plot. And this one is a cumulative relative frequency. What makes this considered cumulative relative frequency? What's that word? Good, because it's in percent. So this was a cumulative relative one. Very good. So now that you understand the basics of this, I want to first ask you, what if you could figure out what this point right here means? This point, which is 70, 60. Of course, the x-axis represents what? Number of M&Ms. Good. And the y-axis represents what? Percent. So I want you to think for a second about what that would mean in context of this problem. If you had to write a sentence about that point, what does it mean? So let me give you a few seconds to think about it, and then we'll discuss. You can talk to your neighbor about it if you want. I'll talk, see what you think it means. And these are percent of students. Okay, so anybody want to take a stab at it? What do you think this might be telling you? Back table, y'all got a stab at it?
Is it 70, like 60% of the total number of M&Ms, 70, 60% of it?
No. 70 is not 60% of the total number of M&Ms. That's not what that says. Okay, what do you think, Bryson?
That would be that 60% of students have at least 30 or more of each, 30 M&Ms of each color.
You're on the right track. You got it started correctly, but this at least 30. So he said 60% of students have at least 30 M&Ms or more. That's getting closer. Brooklyn, what do you think?
60% of students have at least 70 M&Ms.
Okay, and at least 70 M&Ms would mean they have 70 or more. Now, how does accumulation work? Anybody want to take one more stab at it? Accumulation is what has happened so far. One last try. What do you think, Tyler?
At least 60%. 60% of students have at least 30 M&Ms up to a maximum of 70 M&Ms.
Yes, and we might not even be that specific. 60% of students is an awesome start, and even though a sentence is not supposed to start with a number, we're going to do it just for simplicity's sake. So let's start it out. 60% of students, that's the right start off, have, and we're just going to go 70 M&Ms or less. Now, Tyler had added more detail to that. He said 30 up to 70. Now here, I get that I'm saying 70 or less. We kind of typically don't quabble about that, like exactly that 30, 70 at this point, okay? So 70 M&Ms or less in their cup. Okay, so there you go. So that's the contextual component. Computers and programs can spit out data, but it takes you, the humanization factor, to be able to understand the context of what's going on. So let's take a look at this next page. Let's practice what all we got going on here. This is great school enrollment and ages of the students enrolled in 1996. So one thing that we can easily see, since we've been dealing with frequencies, is the percentages. What type of graph have we dealt with so far where we were interested in the percentiles or the percentile? Box plots, very good. In particular, which percentiles were we interested in? Q1 was at the what? 25th percentile. So look at what I can do here. I can say at the 25th percentile, so come here to your data, what age student is at the 25th percentile? Can you see that? What age student is at the 25th percentile? Looks like 6.5. So 25% of students are age what? 6.5 or less. Okay, find the median age and find the Q3 age. Do that now. So your 50 percentile. So the median looks like it's at what? Okay. And the 75th percentile looks like it's at 16. So see, that percentile is that much or less. If you're in the 90th percentile, then you are higher than 90% of the students, or you have more. Okay, but I want to show you what is something cool that we can do as we're building this. We can actually kind of mimic a box plot down here at the bottom, and that's what we're going to kind of do, is build ourselves a kind of superimpose a box plot as we build this, because we already have the scale and we just made the box. So if we're doing a box plot, we got scale, box. What comes next? Yeah. Good. Scale, box, fences, whiskers. And could we compute our fences here? Yep. So let's do it. Upper fence. Go for it. That's going to be my Q3 plus 1.5 IQRs. 30.25. So I'm going to put that fence over here. Okay, and then let's do my lower fence. I'm not really even going to do much. I'm not even going to fully compute this because I can tell I'm going to get a negative number. Can I have negative ages? Am I going to have a lower outlier? I will not, because it's a negative value. So it's way down here. It's off the chart. So I'm not even going to mess with that. So if I was to talk about outliers, where do I have any? Yes, it's these up here. However many that is, I do not know exactly how many that is because I do not know what total students I'm talking about. So what can I say about this amount of outliers? At least one upper outlier. Very good. So that's what I do know about that. Okay, so then essentially, you know, I can tell, I do not know how many outliers I have, but I know I've got some up here because I can see my 100% is going to be even out here somewhere. So let's think about what this box plot would look like. Your whisker is going to go up to the fence. It's not necessarily going to touch it unless there is a piece of data on that fence. I don't know that. So I'm just going to kind of say, don't touch it because we're usually not really supposed to unless there's a piece of data on there. And then I've got my little outlier somewhere out here. Let's draw our lower whisker. Our lower whisker looks like the minimum age is maybe 2 3/4 old. So if I was to talk about a shape of this box plot, what kind of shape would you consider this box plot to be? Skewed to the right. So look at all that information that you can get from this ogive. The percentiles, the center, the spread, the shape of the distribution. You can get shape, outlier, center, spread. Oh my gosh, you can describe the distribution with your socks from that picture. Okay, so let's answer all these questions here. The 25th percentile, what age or less? Good. 50% was what age or less? 75% was what age or less? Our IQR then was 9.5. Are there any outliers? At least one upper. So just get used to giving all that information. At least one upper outlier. What is the shape of this distribution? It was skewed right. And now I want you to, in your own words, state in context what this point right here means. So age in years, I'm going to just kind of put what the X and Y axis says this is. This is the percent of students. Okay, so in context, we can say 95% of students are 29 years old or less. Very good. So I'm going to give you just a few minutes. Let's give you 5 or so minutes to do this on page 33 all by yourself, including problem 12. I'm interested to see what you think about these zero slope sections here, here, and here, and then I'll come back and I'll give you the answers for this page. Okay, so we'll go ahead and take a look at what you had put there. So I identified this Q1 there at 8.5, the median at 10, and then the Q3 at 11.5. So therefore my IQR is 3, median 10. Then I did my fences, and you can see here I computed them at 16 for an upper fence, and no data goes past that. So there was no upper fence. So I was able to then just draw my whisker out here to, it looks like 15. And then my lower fence of 4 does have this data here below it. So I do know that there's at least one lower outlier. I don't know how many, but at least one. Now, be mindful, I'm drawing this whisker kind of right up to the fence. I don't know if it touches the fence because I don't know if there's a piece of data there, because remember, you're not supposed to really touch the fence unless there's a piece of data there. So we can kind of see the shape of this because we know we've got additional stuff down here. We are going to say it's skewed left if we had to ask the shape. But then the interpretation of this was that 70% of the students got 11 hours of sleep or less last weekend. Now, this was a kind of a new idea. We were wondering what is going on with this zero slope. So zero slope, you can think of that. Zero slope, zero change. So there was no additional students in these sections reading these particular, whatever these amounts of books are. We don't really know. Well, it's 40, 60, and 80 maybe. So there were no students that read those amounts of books. And so that's the interpretation of how you handle that zero slope in an ogive or a cumulative graph of some sort. So the assignment I want you to do is, of course, that page 30, which was the transformation page practice. And then 34 to 37 is the ones that will practice on these cumulative frequency curves.